Good day, grade 12s. Today we are going to be looking at technical mathematics. The topic that is going to be part of today's lesson is financial mathematics. It's the 23rd of September 2020. And now, before we can start our lesson, because now we are about to go and write the final examination, so make sure that you have all the previous question paper for technical mathematics. Remember this subject, it was first written on the 2008. It was the first paper. So if you can just go and try to get all those question paper from 2008 and then having the examples for that question, technical mathematics, it's very important. Also, you must get the examination guideline for technical mathematics so that you can be able to see what are the things that you need to know before you can go and write the trial examination or the final examination. Now let's get into the topic for today, which is financial mathematics. Now this topic, remember, is form part of paper 1, and then it contribute 15 plus or minus 3 marks for paper 1. And then under financial mathematics, you will get what? First, use the simple and compound interest growth and decay formula. So you must be able to use this formula of growth and decay, whether it's simple or compound interest. And then the second one is the straight line depreciation and depreciation on reducing balance. Those are two methods. The first one, remember, is straight line method and the reducing balance method under depreciation. And the last one, then we'll be looking at the nominal and effective interest rate, where you are going to be calculating nominal to effective or effective to nominal. So we have a specific formula for that. So it's very important to know on how to calculate using that formula. But the fortunate part is that we have all those formula on the formula sheet when we go and write our final examination. So there is no need for us to memorize all those formula. You just have to know when to use which one or which formula. Then that is very important. All right. Now let's get into today's questions and see what are we going to get. First, I just want to explain the issue around the simple interest and the compound interest formula. And then first we have A for simple interest. A represents the final amount or the accumulated amount. And then we have P there. You can see from the formula we have P. Let me just show you. We have P, and P is the present amount or the starting value. And then I is what is interest rate in terms of percentage. And then N is the number of time period or number of years. And then we go to compound interest. A is still the same with the simple interest, which is the final amount or the accumulated amount. And then P is the present amount. I is the interest rate in terms of percentage. And remember, every time when we are giving an interest rate, we divide that interest rate with 100. All right. And then N, we have what? N is the number of years or number of time periods. Now, under this compound interest, we have a different compound period, right? Because every time we will get a question that gives us a compound period. Now, sometimes it will say to you compounded monthly or compounded weekly, daily, semi-annually, quarterly, and the last one is annual. So every time when this money is compounded in terms of these periods, you must be able to know what number are we using. For instance, if it say compounded monthly, we're going to use what? 12. Compounded weekly, we are using 52. Compounded daily, we are using 360, 365. Compounded semi-annually, sometimes they say it's half yearly, then we're using 2. Quarterly is 4, and annually is 1. Now let me try to explain why 12 for monthly, why 52 for weekly. Now remember when we if a money is invested, right, to a certain percentage per annum, compounded. Now remember when you talk about per annum, we are referring to a year. Now in a year, how many months in a year is 12? Hence we are having 12 there. And then weekly, how many weeks do we have in a year? We have 52. The same applies daily. We have how many days in a year? 365 days. Now, semi-annually or half yearly, it say 2. So what does it mean? It means in a year, we've got semi-annually. Half of a year is the first 6 months and the second 6 months. Hence, is we are having 2. So semi-annually, meaning half of a year is the first 6 months and the second 6 months. So we have 2 6 months. And then quarterly, of course, quarterly is 4. And then quarterly, remember, we're counting the first 3 months, the second 3 months, until you reach the last month, which is the 12th month there. So quarterly is going to be 4 because we have got with the interval of 3 months is 3, 6, 9, 12. So hence we are having 4. And then of course the last one is the compounded what annually we said it's a year, then it's 1 there. We have only 1 year. All right. And then now let's proceed and see what we can have. The example under simple and compound interest. Now let's study this scenario and try to answer this. Sibongile invest 4,600 for 4 years at 10% per annum simple interest. You can see 10% per annum for simple interest. Thereafter, she invested the accumulated amount, the money after investing this 4,600 for 4 years. Then we take that amount that we're going to get, then continue with that amount and say it's for another 2 years, for 12 months, 12% per annum compounded interest. Calculate how much money she will have saved at the end of the 6th year period. Now, if we can study from this scenario, first 4 years is this amount of money which was invested for 10%. It is going to be calculated simple interest with a simple interest formula, and thereafter the money that we are going to get after calculating using the simple interest formula, then we are going to continue with that amount, and then that is amount which is accumulated after 4 years. Then we continue with that amount for the next 2 years, but now the interest changes to 12% per annum compound interest with the compound interest now. And then let's see how do we calculate that. The first for the first 4 years with a simple interest formula there, then you just substitute the value of P and then plus 1 and then I 0,10. Remember, I have also explained that every time you divide your interest rate with 100, then it's going to give us 0.10 times 4, which is 4 years. And the answer that we are getting is 6,440. That is the amount of money that we are going to get after 4 years using the simple interest formula. Thereafter, she then invests this amount of money, which is 6,440, for the next 2 years. But now the interest changes to 12% per annum compounded interest. Let's see, how do we calculate that? First, you write the correct formula for that. Actually, it was supposed to be n there, not 2, because we have to first write the standard equation for the compound interest. The second question, it says P is what? Is 6,440 plus 1. I is 0.12 to the power of n. Number of years is 2 years. All right? It's 2 years. And therefore, the answer that we're getting is 8,078.34. That is the amount Sibongile will then get after a 6-year period. That is the amount of money she will get. All right. And then the other issue that I wanted to emphasize on these two questions, or two approach, the first one, it was simple interest. The other one is the compound interest. Is the issue of what? Let me just check on this one. I did explain this one is supposed to be n there. And then, all right, the formula for the first interest, simple interest, is correct. And then the formula for the compound interest is also correct. Now, remember we said that from the scenario, this person, she then continue investing this amount of money which is accumulated, meaning after we have received money after 4 years, using the simple interest, which was 6,440. That this is the amount which was accumulated. Then we continue with this amount, not which one, not this one, which was initially invested, which is 4,600, and not that amount, right? Okay, now let's continue and see what we are going to be getting after this. What amount must be invested for 2 years at the interest rate of 10% per annum compounded half yearly? You can see compounded. Now we have to think about the compound interest formula, but now we are now adding what? The period. Remember earlier on, I was explaining the issue around period, different types of period we have under compound interest. Then you say compounded half yearly in order to receive what? In order to receive this one. Now it's very, very important, my dear learners, that every time when you read a scenario, write your data down, write what you have from the scenario, so that you can be able to see what you don't have. But it's very clear from this scenario that what amount of money must be invested. Remember we said P is the amount of money that should be invested now. P is the present value or present amount that you are having right now. Meaning what amount must be invested now for us for 2 years, for us to receive 10,000 at the later stage, which is going to be the future amount. Then obviously this 10,000 is what is the value of A. Now you first write the correct formula for the compound interest formula, and then we said A is 10,000 because we want to have 10,000 in after 2 years with the interest of 10%. We want to have 10,000. Now we want to see how much money we should now invest now. We should invest now. So which is going to be the value of P? Then we have to calculate for that. And then of course, I is the 10%, and then we set 10%. You are dividing with 100, which is going to give us 0.10. But now remember we said, I also explained the issue around compounded period. This one is say compounded half yearly, and we said half yearly is 2. Then how are we going to work with this 2? Then first we are going to divide your I with this 2. You can see here is 2. Then divide the number of years with it. So that's how you should now work with compounded period. You divide I with that compounded period, and you also multiply the number of years with that compounded period, like the way we did on this one. And then after you just press your calculator, this is going to be 4. 2 times 2 is 4 there, and then inside the bracket there we add 1 with this fraction, then it's going to give us 1.05. Because now we are in need of P, we want to calculate for P. Surely we are going to divide both sides with this bracket with the exponent 4. We're going to divide both sides, and then let's see this what we did there. And then the value of P then is 8,227.02 cents. So this is the amount of money that we should invest now in order for us to get 10,000 after 2 years with the interest of 10%. I hope it does make sense. And then let's continue. We still have example under compound interest. All right. If Jane wishes to have 120,000 in 5 years, this person wishes to have that amount, which is 120,000 in 5 years' time. How much money she invests if she guarantee a return of 8%, 8.5% per annum compounded monthly on investment? How much money she invests? It means this person also need to know how much money she will invest in order for her to obtain or to accumulate 120,000 in 5 years' time. Let's see how do we do that. First, compound interest, then the value of A, then we need P there, then I is it was 8.5 divided with 100, which is 0.085. Then because it says compounded monthly there, we're going to use 12. Then 12 we divide I and then multiply the number of years with it, and therefore you simplify, you divide both sides with that bracket, and then you just press your calculator there. Then the answer that we are getting is 78,569.99. So there is the amount of money that Jane she is supposed to invest, right? This amount of money she must invest in order to get 120,000 in 5 years' time. Now, Debo wishes to have 25,000 in his bank account in 5 years. If the interest is compounded semi-annually and he's investing 13,760, what interest rate he required to fulfill his wishes? Now, in this case, you can see it's very clear that now we are looking for the I. We are looking for I, the interest rate. We are looking for the interest rate because now we are having which is A, which is 25,000, because this person wishes to have this 25,000. Then meaning, remember, is future value, something that you wish to have or to get or to accumulate after a certain number of years. But now this is A, and then N is 5, and then P is 13,760. Then we are looking for I. And let's substitute and see what we are going to be getting. And the first step that we have to do, then we have to divide with 13,760 there. And then this is what we did. Now, because we are calculating I, then we need to get rid of this exponent 10. Then we're going to multiply that 10 with 1/10. And then what we did on the left-hand side, we must also do on the right-hand side. This is what we did, which is 1/10 there. Then this is going to give us 1. Then we're left with 1 plus I, and therefore we're going to transpose that 1 to the right-hand side, and it's going to be negative. Then you minus both, then you times with 100 so that we can see in terms of percentages, it's going to be 6.7%. That is the interest that this person need to have in order to have this 25,000 in his bank after 5 years. All right. An amount of 25, let me check this one. An amount of 2,500 is deposited into saving account at 14% interest rate per annum, compounded quarterly. Calculate the nominal rate. Let me just underline this one. Calculate the nominal rate per quarter which savings account will accumulate. Let's see. First, for us to calculate the nominal interest rate, then remember I said the interest, you then divide this with what? With 100, which is going to give us 0.14, because now they say it should be per quarter. Then quarter we said is 4, then we're going to use 4 there. You divide both sides with 4. I mean, we divide 0.14 with 4, then it's going to give us 0.035. This is the interest rate of nominal rate, right? The second question says determine the effective rate per annum correct to 1 decimal. Then now we write the formula where we are going to be calculating the effective rate. Now, this is the formula. The second step, what you do, you then substitute the I nominal rate, which it was 0.14, and then M stand. Remember, M does not stand for number of years, people, but it stands for compound period, and then compound period is quarterly. Hence, we used 4, and then to the power of 4 there. And therefore, what you do, you then transpose this +1 to the right hand side there, then it's going to be -1. You just press your calculator, press everything on your calculator, then you're going to get 0.14752. You multiply by 100, then the percentage is 14.8%. That is the interest for that, right? And then the second question, calculate the amount of money in the savings account at the end of 7 years. And then this the amount was deposited, which is 2.5, and then I 0.148, which is the effective rate, and over 4. And then how does we obtain 28? Remember, it's compounded quarterly. We said 4, how many years there? 7 years. So 7 times 4 is 28. And then you go just press your calculator, then you're going to get 6,941.25. Say that is the amount of money that this person is going to receive after 7 years. We're having example 2. All right. Mabeka Construction Company bought a second-hand TLB machine. As shown below, you can see this is a TLB machine. This company bought this second-hand machine. The TLB machine cost 600,000 from a dealership. The company paid 18% deposit and took out a bank loan to pay the remaining amount. Meaning, this company paid 18% deposit of this amount. The remaining amount that needs to be paid, then this construction company then went to a bank and borrow the remaining amount. The bank charges 15% interest rate per annum compounded monthly. Calculate the amount the company loaned from the bank. Calculate the amount the company loaned from the what? We want to know how much money is this construction company borrowed the money from the bank? How much money this company loaned from the bank? Since they have paid 18% first, and then they borrowed the remaining amount, we want to know how much it was that. Now, first we're going to calculate the 18% of 600,000. Then that amount is going to give us is 108,000. 108,000. Now, the amount the company loaned, because they loaned the remaining amount that we want to see. So it's going to be 600,000 minus 108,000. Then the amount is 492,000. That is the amount of money this construction company borrowed from the bank, because it was the remaining amount. Example of changing interest rate. Calculation involving changing interest rate. Now we'll be learning on how do we approach a question or a scenario where we have more than one the interest rate, because we have seen that we have been calculating using only one interest rate from a scenario. Now, if you have more than one interest rate, how are we going to calculate such a question? And then from this example, it says 50,000 is deposited into saving account. The interest rate first 3 years of savings is 12% per annum. Per annum compounded half yearly. Thereafter, the interest rate changes to 18% per annum compounded monthly. The money is left to grow for further 4 years. Calculate the future value of the investment at the end of the 7 years savings period. Let's see on how to approach this question. First, we write the correct formula for the compound interest. Then this is the step that I want us to look at. First, remember P is the amount of money which is deposited, the initial amount, which is 50,000. Now let me explain this, the first bracket. From here, it says the interest rate for the first 3 years of savings is 12% compounded half year. Then we need to write that bracket. Now it's 1 plus, what is the interest rate for the first 3 years? Is 12%. Is 12%, right? And then which is, you divide with 100, then it's going to give us 0.12. Now, because it said per annum compounded half yearly, and we agreed that half yearly is 2, we divide with 2. And then how many years is 3 years times 2? Then it's going to give us 6. Now multiply by another bracket, because it says therefore the interest rate changes to 18% now, compounded monthly. Then it's going to be 1 plus 0.18, because now that interest is no longer 12 but is 18%. Then you divide with 100, which is going to be 0.18. Compounded what? Monthly. Then you say divide by 12. For the remaining years, because now we have from 7 years, we have taken out 3 years, that is going to be 4. So it's 4 times 12, then it's going to give us 48. Then you just press everything on your calculator there. Then you're going to get this amount. Let me just remove this. And then you're going to be getting 144,935 rand 35 cents. So there is the amount of money that you'll be getting after 7 years on those two different types of interest rate. Withdrawals and deposit. Now, what is going to happen in this situation? If the money is invested at the later stage, there's a money which is deposited again, or the money is withdrawn again, then how are we going to calculate such question? So let us look into this one and try to understand on how do we approach it. Additional payments and withdrawals. Brenda deposit 5,500 into a saving account. 5 years later, 400 is added to the savings. She's now adding 4,000 again after 5 years. The interest rate for the first 3 years is 14% per annum compounded semi-annual. Thereafter, the interest rate changes to 12% per annum compounded monthly. I did explain this one. Remember, we just did this one where we are having 2 interest rate. But what is new on this one is when the money is added now. How are we going to calculate that? Calculate the future value of the savings at the end of 7 years. We first start with a timeline, because this type of question, it really need timeline, because timeline, it makes things simple and easy for us to calculate. Then first you write from first year to the last year of 7 years, and then you just put your values there. The initial amount which was deposited, it was 5,500, and then after 5 years, then 4,000 is now added, and then we have to calculate for that. First, we say this is supposed to be n there. I don't know why I like to put 2 there. It's supposed to be n. The standard equation is n, number of years. Then now I have to explain this now. Let me try to explain that. P is the amount which was initially deposited, which is 5,500. Now let me explain this one. Now remember the first interest rate, the interest rate of the first 3 years, meaning from here to there, the interest rate is 12%, right? Now we say it's 14%. No, not 12%, but it's what? It's 14%. Let me fix that. It's not 12, but 14%. First 3 years, it's 14%. Thereafter, the interest rate changes to 12% compounded annually, meaning this 12% is the remaining years. That is the 12%. And then we said 1 plus the interest rate of the first 3 years is 0.14. and then it's 0.14. Remember, you divide with 100, this 14%. And thereafter, compounded semi-annually, which is 2 divided with 2. Number of years from 0 to 3 years, which is 3. So it's 3 times 2, then it's 6 there. The second bracket is 1 plus 0.12, because now from this third year to the remaining years, the interest rate is no longer 14, but is now 12. Hence, we are having 0.12, and it's compounded monthly, and then we divide with 12. The remaining years there is 1, 1, 2, 3, 4, which is 4 times 12, then it's going to give us 48. And then, because 4,000 it was added there, then we're going to say plus 4,000. And then from 4,000 to the remaining year, which is 1, 2, which is 2 years, but the interest rate is still the same, which is 12%. Then we're going to say 1 plus 0.12 divided by 12, and then 12 times 2, because from here to the last year is 2, then is 2 times 12 is 24. Then you just press everything on your calculator, then you're going to get 18,368.28 cents. This amount of money that we are getting. All right. Let me just remove this. So that's how we should now answer this question. It was a very interesting question. Now let's proceed. We are now going to be looking at the depreciation. We are having the first one, the straight line depreciation formula, which is this one, where it's having negative. Remember, the simple interest is having positive. So the difference is only the sign. From there, we can now have, so A, P, and I, and N is still the same. They mean the same thing. The same applies with the reducing balance method. Is the same as compound interest, but we only write the sign as negative, not positive. And then the meaning of A and P and I, the same thing. Now let's proceed and continue and see the example under depreciation, how long it will take. Let's listen to this question. How long it will take the investment to have in value if it is depreciated at the rate of 12%, 12.5% per annum on a straight line method. You write the formula for that, which is the formula for a straight line method. Now, because you say how long, meaning we want to know how many years, how long for the investment to have in value. Remember, when you talk about depreciation, the amount of money that we are having now is going to be more than the amount of money that is going to be looking at the in future there. All right. When we are referring to depreciation, normally we are talking about an item that is losing value. I can make a typical example. For instance, if you're talking about a car, and then you buy a car this year with 10,000, how much this car is going to cost after 5 years from now? That car is going to be, the value of that car is going to be less than the current value. So that amount is depreciated, right? It's no longer going to be 10,000, but it's going to be less than 10,000. So it's the item that is losing value, right? Now, because now the money which was invested is going to be half the in value if depreciates, and then we're going to assume that P is 2x, because we don't know that amount, which is going to be 2x, and then it's going to be half after how many years? After those years that we are looking for, there's going to be half of this. So half of 2x is going to be x there. And then I, of course, is 0.125. Then you just proceed there. You then going to divide with 2x, and then it's going to give you 1/2. Then you're going to transpose this positive one this side because we are looking for n, and then thereafter you then divide with 0,125, and then it's going to give us n as 4 years. So it's going to take us for 4 years. The second question says, if an investment of 95,000 depreciate at 6.5% per annum, using the straight line depreciation, determine the value of the investment after 3 years. We are now using what? Straight line. We still under straight line. And then we want to know after 3 years, this amount of money is going to depreciate on how much money. And from there, it's going to depreciate at what? 76,475 rand. So this amount of money after this 95,000 depreciate after 3 years. We have another example under depreciation. If a car costs 85,000, depreciate at the rate of 12% per annum for 3 years, use the reducing balance method. Determine how much car after 3 years it will cost. This car. Now we are using reducing balance method. Let's see on how do we calculate. We want to know how much money, how much this car is going to cost after 3 years, which is A. We are looking for A this time. And then P is 85,000, I is 0,12, and N is 3. Then the amount of car is going to be 57,925 rand and 12 cents. That is the amount of money the car is going to cost after 3 years. Determine the rate of the depreciation that will be used if the car depreciate from 120,000 to 65,327.80 cent in a period of 5 years on reducing balance. We want to calculate the interest rate in this time. You write the correct formula there, and then you substitute correctly. Then now we want to make I the subject. You first have to divide both sides with 120,000. Thereafter, we want to get rid of this exponent 3 because we are looking for I. Then you multiply with 1/3, and then what you did on the right hand side, you must also do on the left hand side. And then this what we are having, and we're going to transpose this one to the right hand side, and then you then divide with negative. It's going to give us I 0,1918. Then you multiply by 100, and it's going to give us 19,19%. That's how you should now calculate the interest rate, the rate of depreciation actually. We are now into effective and nominal rate. They're saying the nominal rate is the rate that is coded in the question, and then the effective rate is the equivalent annual rate that you will receive once compound has been taken into account in the order to compare the interest rate with different compound period. If it is often used to convert nominal into effective rate. So this is the formula that we are using to calculate nominal and effective rate. Remember earlier on we also had a question where you have to use this formula there. So I think it's not going to be difficult for us to answer this one. Using this formula there. And then of course I with effective is effective interest rate, I with norm the nominal rate, M is the number of time period. Here the nominal interest rate is compounded. It's not a number of years, but is the compound period that we are having. Now let's get an example from that and see on how do we calculate. The first question says we should now convert the interest rate 15% compounded monthly to effective interest rate. Let's do that and see. You write the correct formula there. Then the second step, you're going to substitute your nominal rate, which is 0,15. You always divide this interest rate, like I've said, with 100 so that you can obtain 0,15. Then compounded what? Compounded monthly, which is 12 and 12. And then therefore you're going to transpose this positive one to the right hand side. As you can see it there. Sorry, let me just try to remove this. And there, from there, you can just press your calculator, everything on your calculator, and you give you 0.1008 times with 100, then it's going to give us 16.08%. The second question we have to now, interest rate of 8.25% compounded quarterly effect to effective interest rate. We also need to convert that into effective interest rate. You write the correct formula for that. And then the second step, you then substitute, you divide this with 100 is going to give us 0.0825. And then is compounded what? Is compounded quarterly. Then you divide with 4 to the power of 4 there. And therefore, then you're going to transpose this positive 1 to the right-hand side. And then just press your calculator, then multiply with 100, then it's going to give us a percentage of 8.51%. So that's how you should now calculate the effective and nominal rate. So sometimes they can ask you to convert nominal to effective. It's not always the case that you have to convert to effective interest rate. Thank you very much for being with me on this very interesting lesson. And then let me just leave you with this very encouraging words, which says, our greatest weakness lies in giving up. The most certain way to succeed in this life is always to try, and just one more time. All right. I thank you. Have a nice evening. Thank you very much.